Newton's third law is the most famous and most recited law. Okay, so what is Newton's third law?
Every action has a reaction?
For every action, there is a positive and negative reaction.
For every action, there's a reaction?
Yeah.
For every action, there's always an opposite reaction.
Law.
So it's evident that people know the third law, but do they really understand it? Their misconceptions prevent them from truly grasping the concept.
The first common misconception is that two forces involved in an action-reaction pair can cancel each other out or balance.
Megan and Delage are pushing on each other, and Megan is pushing on Delage with the action force, while Delage pushes back with the reaction force. Which force is the larger?
They're equal because neither of them are falling.
They're equal. They're both pushing. Neither of them are falling, so the forces are equal.
So we can see that they can easily respond to a question using Newton's third law. But can they really understand it?
Megan and Delage do not move as these forces are applied. Why is that so?
Because the forces push against each other, so they cancel.
Well, because Megan's pushing against Dilraj, and Dilraj is pushing against Megan, so they're
The
balanced.
forces don't cancel out under any circumstance because the two forces are being applied to two different objects. The forces can only cancel out if the forces are being applied to the same object. Consider the force diagrams.
If I apply a force on Dilraj, Dilraj applies a force equal in magnitude but opposite in direction on me.
I can't apply a force to myself.
We do not move because of friction. The force counteracting the force Megan applies to me is the force of friction on our feet. Similarly, the force I apply on Megan is balanced by friction on Megan's feet.
Without friction, we would both move away from each other.
First misconception, demolished.
The second most common misconception is that Newton's third law is somehow nullified when motion is initiated. Here we have 6-year-old Alex and 4-year-old Emma. Alex pushes Emma hard enough to make her fall backwards. So who exerts the greater force?
Oh, Alex.
They are both pushing with the same force. Just because one is moving does not mean that Newton's third law goes out the window.
Do you get it? Are you still confused?
Well, Alex must have exerted a bigger force because he pushed her over.
I think he did too. But we know from Newton's third law that interacting forces exert a force of equal magnitude on opposite directions. Consider Newton's second law.
The force on Alex from Emma is equal to the force on Emma from Alex, just in opposite directions. The forces do not cancel because they act on two different objects. So if the forces are the same, why does Emma move? This is due to their mass and not their force. Newton's second law says that the net force is equal to mass times the acceleration. Since the forces are equal, the mass of Alex times the acceleration of Alex must equal the mass of Emma times the acceleration of Emma. Since Alex weighs more, his acceleration will be less. Since Emma's mass is smaller, her acceleration is larger. This causes Emma to accelerate and Alex to remain still.
Second misconception, destroyed.
So we would like to rewrite Newton's third law. For every action, there's an equal and opposite reaction on the other object. Hopefully this clears things up, and we can put Newton's third law back on the table.